Hello. This example is not up to date. I uh, it's about the presidential election 8 years ago. I can't believe it's 8 years ago. It seems like last year, but I've been teaching this for 8 years. Anyhow, by the way, it's not my intention. I wanted to update this, but I will tell you why I can't do this. So 8 years ago, President Obama won the election, and this was a poll result by CNN and ORC International conducted in September 2012. Sample size was 783 likely voters, and marginal error is plus minus 3.5 percent point. So even if it shows a point estimator, actually it is an interval estimator. So it means the same thing. Point estimator, and like if you add and subtract the margin of error, you will get an interval. So the reason why I could not update this example is because I wanted to find a nice graphic, like nice picture, like graph like this, showing the sample size and the margin of error at the same time. But I tried to find additional, like more recent updated result, but like most of them have only one of them, either the sample size or the margin of error. But we need both. You will see why we need both. And if you find one, let me know. Send me the source, and I am going to use that from next year. Anyhow, and here usually confidence level is not revealed because most of them use 95% level. So this is the standard in this profession, in this work, in estimating the presidential election, predicting the election. So this is the standard level, so it is not reported. And so this is, as you see, the presidential election prediction is an important estimation problem. And statisticians do work on this, and like from many different dimensions. And you may have heard about the story about Gallup. Gallup, the name of the survey company, was founded by a statistician named Gallup, and he predicted how wrong the existing prediction is. So there were some existing like companies predicting the election, but Gallup predicted how much they are going to be wrong. So that was correct, and that's how he became famous and founded the company. Anyhow, I'm going to explain how we use the same framework we learned to presidential election example. First thing you have to understand here is that the underlying distribution for a single outcome is a binary distribution. So suppose that x, a random variable x, takes 1 or 0. So you randomly choose a person, a voter, and ask if she supports for candidate A, a certain candidate. If yes, it takes 1. If 0, it takes otherwise it takes 0. So if she supports another candidate, then it is 0. And so this is the underlying 1 or 0. And when you collect more people, when you survey more people, it will become a sample, a random sample. And often we are interested in the percentage supporting for candidate A. So, like of course, in presidential election, we are interested in the percentage. We are not interested in like standard deviation or anything else. Median, they are not of our interest. Percentage is our parameter of interest. And remember, the parameter of interest is probability that the survey respondent supports candidate A, x equals to 1. And remember, it equals the mean. We learned it in chapter 5. If you don't remember what's going on, then go back to the chapter and watch the video or read through the slides. Anyhow, you may just take it as granted. So for any binary distribution, the probability of success equals the mean. So therefore, we are estimating the probability of success, but actually, you may view this as an estimation of the mean. So we are estimating the mean. So we may use the same procedure we learned so far, right? That's what I meant earlier. So when you learn how to estimate the mean, you may apply that to many other cases. This is one example. And we are going to use the previous, the procedures we learned. And another thing you have to understand in here is that the underlying being a binary distribution does not change the formula, because the formula depends on the central limit theorem and standard normal distribution, and they hold like no matter what the underlying distribution is. So binary distribution does not cause any problem there, but the only problem we have is how we calculate the standard deviation, because a binary distribution has one parameter, p, and it determines the standard deviation, right? So remember, variance was p times 1 minus p, probability of success times probability of failure, and square root of standard deviation is the square root of that. So we are estimating the probability of success p, which determines the standard deviation again. So it's a little bit tricky flavor to the problem. Anyhow, let's see how we handle this. So then what we have is we would like to construct a 95% confidence interval for the probability of success, or the mean. You may interpret this as the mean. I'm going to call it as the mean. And suppose that your data consists of 400 likely voters, but 320 of them support candidate A. So 80% is a lot, but I just wanted to choose a number that make the result simple. So suppose that 80% of people like candidate A. And the formula is the same. We just need to compute x bar, z alpha over 2, s, and square root n. The sample mean is the sample. Again, now the sample mean will be interpreted as the sample probability of success. They are always the same. So when you interpret this way, it is easy to calculate. 0.8 is the sample mean. And the standard deviation based on the binary distribution formula is 0.4. So this is why the square root is very simple. Square root of 0.16 was 0.4. So it is easy to calculate. So that's why I use 80%. So 0.4 is the standard deviation, and sample size also easy. And 95% confidence level implies 1.96. So we are done. Plug them in. Margin of error 1.96 times 0.4 divided by 20, which is 0.0392. Or it means the margin of error is 3.92% point, right? 3.92% point is the margin of error. And point estimator is 80%. And then subtracting and adding the margin implies the parameter lies between 76.08 to 83.92%. So this is how we use the confidence interval to the example of presidential election prediction. Now, now we can apply the same survey design again here. Suppose that you want to, like previously, the margin of error is 3.92 percent point, but you want to reduce it to 3.5 percent point, which is also a kind of standard, and still at the same confidence level. Then how much sample do we need? Also easy. Margin of error should be smaller than 3.5%, which is 0.035. Z value is the same, 1.96. Standard deviation from the existing data is 0.4. Then we have to solve it for the sample size. By the simple algebra we did, you have 501.76. So you need 502 observations. Then you can achieve 3.5 percent point margin of error. All the theory holds in this example, and this is actually the basically how the survey is done. Now it's your turn. Like slightly change the number. You surveyed 400 voters, and 200 of them like candidate A. What is the margin of error to estimate the proportion of voters supporting candidate A at the 95% confidence level? Please do it by yourself first, and then continue watching this video. I'll turn to the page. 3, 2, 1. So we have repeated this several times. The Z value is still 1.96 because it's again 95% confidence level. And standard deviation is now 0.5 times 0.5 square root, because out of 400, 200 people liked candidate A, which is 50%. So P from the sample is 50%. So sample standard deviation is square root of 50% times 50%, which is 0.5. Square root of sample size is 20. Plug them in. The margin of error is 0.049. So the margin of error is 4.9 percent point. So everything is the same, but like previously, remember, we had 3.9 percent point, but now we have 4.9. The difference is the probability of success. So because probability of success determines the standard deviation, when you change the probability of success, the standard deviation changes, so it affects the margin of error. So the margin of error depends on your sample average. And I will give you another question. In the same setup, like 400 and 200 out of 400 case, what is the minimum sample size to have the margin of error smaller than 3.5 percent point at 95% confidence level? Again, try it. Structure is the same. We'll turn to the next page. 3, 2, 1. The margin of error must be smaller than 0.035. Can be written in this way, which again implies n must be greater than something squared, and it is 784. So we need 784 sample size respondents, and surprisingly, that's the number they actually used. CNN actually used. The difference, like why it's not 784. Maybe I guess there was some rounded decimal errors which may affect the sample size. So anyhow, I showed you what I teach you is not just something something totally absurd. It's basically what statisticians do in our daily life. So I hope you find it interesting. And I'm going to continue. I will have a short, brief remark in general in the next video. So see you in the next video.